warm welcome to all who have joined us. Thank you for joining our today's webinar. We are back with another interesting topic today. The topic of today's webinar is transforming supply chain resilience with SAP S4HANA Advanced available to promise. So in this webinar, our experts will provide a comprehensive overview of reimagining order fulfillment and offer actionable insight into how Yash can help businesses leverage advance available to promise to their advantage, which would include precision delivery timelines, minimizing stockouts and overstockouts, touchless fulfillment automation, reduced cost, increased efficiency, and also the dynamic order management. Now, to cover this topic, we have on the panel today Mr. Firdosh Kotwal. He is the head SAP Digital Supply Chain Practice at Yash with over 27 years of experience. We also have Mr. Gaurav Subhash Kulkarni, Head of Supply Chain Practice. Gaurav, would you want to have a quick introduction from you?
Yes, sure. Thanks, Naveen. So, hello everyone. My name is Gaurav Kulkarni, and I am working in supply chain for last 15 years. I have worked in several SAP modules from a technical background in ABAP as well as SD, APO, GATP, and several different ECC modules. And now I'm heading the supply chain GATP practice, GATP and aATP in Yash Technologies. So excited to connect with you all.
Well, thank you, Gaurav. Thank you all. Apparently, Firdosh Kotwal, due to some medical exigency, he's not able to join us. But yeah, we promise to bring him on our next session. And of course, I'm your event host, Ms. Naveen Rathi. I'll be here addressing all your questions and anything that you want to ask our expert, Mr. Gaurav, today. So please keep putting those questions in the Q&A tab. Moving on, let's quickly go through our today's agenda. So we'll start with the ATP and aATP overview, proceeding with the S4HANA advanced advanced available to promise features, and what are the business benefits which I already mentioned. So Gaurav would be deep diving into it and explaining it to the audience, and then we'll also have the comparison of this particular tool. And then lastly, we have a demo organized for all of you, just to understand all the features and the advantages the tool has. With that, I would like to hand over the presentation to Gaurav. Gaurav.
Yeah, thanks a lot. Thanks, Naveen, for the warm introduction and setting up the stage for aATP discussion. aATP is a very interesting topic, so I'm all excited to discuss about the features and functionalities of aATP. And let us straight away dive into the presentation. Thanks a lot for arranging this, Naveen. So let us start with the impact of not having the optimized order fulfillment processes and what is its impact on the revenues. And so here is the survey which says it has impact of more than 184 million. It costs organizations more than 184 million per year if the supply chain processes are not streamlined or due to supply chain disruptions. This can have an adverse impact on the revenues of the organizations. And for such situations, for such challenging situations, SAP S4HANA's advanced available to promise can be of help for lowering this cost of by 15%, lowering the cost of maintaining the inventory by 50%, and it can speed up the order to cash cycles by 3 times. So this way, advanced available to promise can help reduce the impact of supply chain disruptions. We have seen several disruptions in recent years, from COVID to the recent wars in Middle East. So these global tensions and such global situations can impact supply chain and cause huge disruptions and impact the revenues. So aATP can help mitigate such impacts, if not eradicate, but it can help massively mitigate the impacts of such disruptions. We'll discuss about the aATP features and functionality. We'll try to understand what is available to promise and several new features introduced in S4HANA. Let us proceed. So when we talk about aATP, the main part about advanced available to promise is first available to promise. So let us understand what is available to promise. Available to promise is the quantity uh, that we can promise the customer to deliver. So there are three main components: which material we want to deliver, how much quantity we want to deliver, and on which date we want to deliver it. So these are the important factors when we talk about available to promise of a material. And this ATP check of a material was available in previous ECC versions as well. It has been a part of ECC from many years. So normal sales order in SAP ECC use this normal ATP to check the availability of the material. Now this is a simple standard SAP process that has been a part of ECC for many years, and this is useful in a simpler environment where we have to check material availability in a single plant. There's no complex supply chain networks, and uh, it is it is a simple. The advantage of this is it is simplicity. At the same time, it has a limitation of first comes first serve. Like if we have certain quantity of material available, the customers who place the order first are able to consume all the inventory. And even if we have priority customers who place the orders later on or whose orders are delayed, they end up not getting any material. So that is the limitation of this process. On one hand we have the simplicity, on other hand we have this compromise of first come first serve problem with the simple ATP. Now comparing it with the simple ATP with the advanced available to promise, aATP has several different functionalities which help provide the flexibility to use this tool more efficiently to maximize business benefits, revenues, and improve the order fulfillment. So PAC is a normal product availability check in SAP aATP. Back order processing, like the name suggests, deals with the past orders which are not fulfilled or partially fulfilled, and it helps in reprioritizing the orders. So, if we have to reorganize or redistribute the materials from low priority customers to the high priority customers, uh, the stock situations or the inventory situations change, and we have to adapt to the new changed situation. If a rush orders coming at the latest time, then we can use back order processing for such situations. Product allocations is the functionality where we want to have control over the distribution of the material. So product allocation is generally used where we have a lot of demand for a product and there is a less supply. So in such situations, when we wish to have more control on the distribution of the product, and we need to have control over how much quantity needs to be delivered to which customer. In such situations we can use product allocations to set up a quota for customers so that the allocated quota will be consumed by that customer, and uh, the fair share policy can be used. The released for delivery app is a Fury app in S4 HANA which helps to accommodate last minute changes. So even even after using several planning tools, even after using back order processing at the last minute, at the before the shipping is done, if it is required to change the sales order confirmation or to change the quantities distributed to the customers, this release for delivery app helps to fine tune the last minute requirements to fulfill the sales orders. ABC is the functionality in aATP which helps to confirm the sales order based on the availability of material from alternative plants. So we'll discuss this functionalities in detail going forward. So in a nutshell, the previous ATP functionality which was present in ECC had several challenges. Those challenges are overcome by advanced ATP in S4HANA, and the solution has been more refined, more functionalities has been added to aATP, and we'll discuss these functionalities in detail going ahead. So in this slide, we discuss about PAC, PAL, and ABC. So PAC is product availability check, PAL is product allocations, and ABC is alternative based confirmation. So when we talk about product availability check, we discussed about ATP quantities earlier. So ATP quantity is not same as having the stock quantity. ATP quantity is a dynamic quantity. It is very volatile, and it always keeps on changing. So it is a challenge to determine what is the ATP quantity at the current moment. Say we'll take this example here where we have a material of 200 pieces at a particular plant, out of which 150 pieces has already been committed to previously created sales orders. So even though we have 200 quantities of stock of a particular material available, we cannot say that our ATP quantity is 200 because 150 is already been committed. So the ATP quantity becomes 50. So now we have 50 quantity which is available for us to distribute to our customers. Going ahead with product allocations, like I mentioned earlier, is used to solve the first come first serve problem. It distributes a quota, customer wise quota, and it makes sure that customers do not over consume the quantities which has been allocated to them. So here we take example of three different customers: customer A, customer B, and customer C. Here we have generated allocation for quantity 30, 20, and 15 respectively. Once these allocation quantities have been assigned to these customers, if their orders come in as per the given example, customer A places the order of sales order quantity of 50, customer B places the sales order quantity of 30, and customer C places the sales order quantity of 10. So as per this example, the customer A will only receive confirmation of 30 because he has allocated quantity of 30 only. Even if the sales order quantity is more, the customer A will only get confirmation up to maximum limit of 30, which is the allocated quantity. So this requested quantity of 50 can be of a single sales order or can be of multiple sales order of different requested quantities. So the cumulative consumption would be limited to 30. Similarly, for customer B, the cumulative consumption would be limited to 20. Now, in the case of customer C, when the allocation is 15 and the customer has requested 10, he will get the full confirmation as he has not exceeded the allocated quantity. In case of customer A and B, there will be partial confirmations. In case of customer C, he will get a full confirmation. So product allocation acts as a maximum quota that a customer can consume. Going ahead with alternative based confirmation, it generally happens that the inventory lies at a particular plant and the sales order that the customer places is for a different plant, different location. So in such situations, generally what is needed is we transfer the material. Generally people transfer the material from one plant to another plant through STOs where there is a high demand, or manually have to fiddle with the sales orders to do the changes in the sales order. Here using alternative based confirmation, we can check the availability of the material at different plants and provide the confirmation from that plant. And This functionality of ABC in S4HANA, SAP has provided different algorithms, order confirmation algorithms, which has full confirmation, max earlier confirmation, and on-time confirmation. So this is implicit logic built in this functionality, where if we use this algorithm during our setup or system configuration, system will respect that. And if I place a sales order at a plant where there is no material available, if I use the first strategy of full confirmation, system will try to see at which plant, which location full confirmation is available. So whichever plant fulfills this criteria, sales order will be confirmed from that location and full quantity will be confirmed. On the other hand, if we use max earlier confirmation, system will try to fulfill the requirement as early as possible. Even though full quantity is not confirmed, whatever quantity system is possible to confirm, it will try to confirm at the earliest from a different location. On-time confirmation is like the name suggests, uh, system will try to match the requested delivery date from the sales order, and whichever plant fulfills this requirement, is able to fulfill the requirement of requested delivery date, system will capture that plant in the sales order and try to fulfill the sales order from that plant. So this is very flexible functionality. Earlier it was in the earlier versions of ATP, like AP or GATP, it was rule based ATP for confirming the sales order from different plants, but that was very rigid and the rules were prior set, and the system used to perform as per the set rules. Here these implicit logics of full confirmation, max earlier confirmation, they are not rigid, they are flexible, and system deduces or determines the plant based on this predefined logic. So it is not one is to one hard constraint. Going ahead with the back order processing, deals with the reconfirmation of the sales orders, and generally if when the supply situations or supply and demand situations change, and if we need to reconfirm the sales order or rematch the demand and supply situation, back order processing is used. It is generally used as a mass background processing job, and it reconfirms the sales order as per the predefined logic. In the earlier versions of back order processing, uh, generally we used to select the sales orders that needs to be processed, and we used to prioritize the sales orders based on date or different factors and just execute it. Now in S4 HANA we have these different functionalities of lose, fill, redistribute, gain, and win. These are also the implicit logic built into SAP aATP, S4 HANA aATP, and there is a specific behavior of each of these implicit strategies. So the strategy of lose is used to delete confirmations from the sales order. Say for example, if you have certain sales orders consuming the inventory, full confirmation or partial confirmation, and later on during the day, if your high priority customers place the orders, to overcome the first come first serve problem, or to change the confirmation from one customer to another, we use these strategies of lose. So lose will free up the inventory which is already consumed by low priority customers, and then we can use redistribute, gain, or win to fulfill the orders of the high priority customers. So using lose will free up the inventory, and then we can redistribute as per our predefined logic to prioritize a certain customer to confirm sales orders of those customers. Fill, likewise, will also reduce the confirmation of the low priority customers. Redistribute, as the name suggests, we have certain amount of inventory available. It will try to redistribute that much quantity as per the predefined logic, as per our priority of the customers. Gain will, when we execute gain, it will always try to improve the confirmation. See, for example, if you have a sales order of order quantity 100, and if you only have 80 confirmed, this strategy will try to improve the situation, but it will not let the order lose its confirmation what it already has. It will retain the confirmation, the orders which already had. And win will always try to fully confirm the sales order. So and these strategies has been very carefully designed by SAP. These were the problems which were earlier faced in the previous versions of ATP. That if, for example, if I have a customer who has already who has placed an order of 100 quantity and I have 80 confirmed, after execution of BOP, if we want the 80 to become 85 or 90, we want it to improve. There were chances earlier in the earlier version that the 80 which was earlier confirmed, that also used to get reduced or unconfirmed. So using these strategy, we can ensure that the order confirmation will only improve and not reduce. So these are the very interesting strategies built by SAP into aATP for back order processing. Going ahead, this is the recently added functionality of supply creation based confirmation in aATP. Supply creation based confirmation is like CTP, capable to promise, in the earlier version, if you may have heard. So supply creation based confirmation, what it does is during the time of ATP check, it checks if the required quantity of materials are available or not. If it is available, order is confirmed. If partial can be confirmed, remaining quantity, system is able to trigger production. See, for example, if I have insufficient stock, this can also be used for MTS as well as MTO scenario. So, for example, if I have a MTO scenario, make to order scenario, I place a sales order. Immediately at the runtime, during the runtime, system checks if the all the required materials are available or not. System is able to check the resource capacities, how many resources are available, how much capacity is available for those resources, when I will be able to produce this material. And by checking all this, system will propose a date on which we can promise to the customer. And this happens during runtime at the time of sales order creation itself. Going ahead, we'll see a demo of this functionality. It is very interesting that during runtime at the time of order creation itself, system checks the capacities of the resources and calculates the time and promise dates. This integrates with PPDS, S4HANA ePPDS, to provide the confirmation dates. We have this recent functionality of supply protection. This is also have been recently added to S4HANA aATP. Using supply protection, we can ensure that the quantities are of a material are reserved for a particular customer. See, if there is a business need that we want to reserve particular quantities of materials for our high priority customers, and we don't want to limit those customers, they can consume more. And to maximize the revenue, this can be used to maximize the revenues. Customer who places orders regularly, pays on time. Uh, so such high priority customers, we need to make sure we have materials reserved for such customers. In such situations, supply protection can be used, and we can define different buckets as per the business needs. We can protect the quantities on weekly basis or monthly basis or as per the business needs. And these are several business benefits for of using S4HANA aATP. The first one is we get advanced functionalities of availability check that considers available stock. It considers the anticipated receipts. We discussed about ABC, SBC, all these advanced functionalities are available in aATP. It has global visibility of checking multiple availability of multiple at multiple plants. It increases revenue through increased order fulfillment. So it reduces the lost business opportunities or uh, unconfirmed sales order due to lack of inventory management. Such kind of issues are dealt with by the system, and the revenue is increased through a better order fulfillment process. For make to order scenarios, we have this SBC, which supply creation based confirmation, which during runtime checks the BOM levels, availability of the components, it checks the availability of the resources and reserves the capacity of the resources. Uh, S4HANA aATP also has simulation of what if analysis. Like for back order processing, these we discussed the strategies of win, gain, lose, etc. So if we want to analyze what will happen if we run a particular strategy, what could be the outcome, we can simulate. We can have a simulation run of these strategies and see what the outcome could be, and if it is as per our expectation, we can actually run the background job after the simulation. S4HANA aATP also has very good integration capabilities with different modules. ePPDS is already part of S4HANA, so it integrates very well with ePPDS. Like for example of SBC, supply creation based confirmation, it integrates with ePPDS. It also has integration capabilities with external systems like IBP, SAP IBP. aATP helps to reduce the stockouts and overstocking. We just discussed that at the time of sales order creation itself, we can trigger production, that too while considering the resource capacities. So in such cases, it definitely helps to reduce the stockout situations by immediately triggering the production. It also reduces overstocking by if the inventory is more at a particular plant and not available at a particular plant, using ABC, we can directly confirm the sales order from different locations to reduce stocks from different locations and better management of the inventory. It improves the decision making, and since the S4 HANA platform is based on in-memory HANA database, in-memory computing of HANA database, it provides high performance, and it is suitable for processing large number of sales orders or sales orders with large number of items. And it has a intuitive interface of SAP Fury. It is user-friendly interface. Going ahead with the comparison of aATP with advanced available to promise. The previous versions of aATP had the capability to check the availability of material at one single plant. Uh, there was no restriction of capping of material quantity that could be consumed by a customer. Also, the order fulfillment mechanism to reassign the stocks from one customer to another at the last minute, just before the goods issue, was not available in the earlier versions. All these functionalities have been provided in the S4HANA aATP. During the shortfall of the material, we can use supply protection to make sure that our high priority customers uh, do receive the material, and uh, to come up with the calculate the come up with the accurate promise dates. SAP S4 HANA also triggers the production, calculates the uh, capacities of the resources, and provides the accurate promise dates. It is also capable to integrate with different external systems and internally with several modules. So these are the functionalities in aATP which has been improved or newly added in aATP, which was not present earlier versions of aATP. In general, in a nutshell, S4 HANA aATP uh, helps to improve the no-touch order fulfillment. Now, by note, what do we mean by no touch order fulfillment? Usually there is a lot of manual work involved in sales order fulfillment. We say, like, once the sales order is created in the system, after that the order fulfillment manager will look at the sales order. If it is not confirmed, he will try to analyze why it is not confirmed. Say, suppose sufficient inventory is not available at that plant, he will manually have to fiddle with the sales order, change the plant or change the quantities, or provide alternative material to fulfill the to confirm the sales order. And likewise, he'll have to confirm the sales order process with the deliveries and all. Going ahead with implementing with S4 HANA, it improves the no touch sales order process. That means there will be the manual interaction or manual fiddling of the sales orders will be reduced drastically. And once the sales order is created, if the it is credit is checked and the sales order is good to go, the sales order will itself check the availability of material at different plants. It will try to confirm the sales or confirm the quantities from different locations. If material is not available, if it is a make to order scenario, the production will be automatically triggered. And using supply protection, if you are using supply protection, will ensure that our high priority customers reduce the confirmed quantity. Once the sales orders are confirmed, if there are any last minute changes required, release for delivery app can be used to accommodate those last minute changes. And the sales order is released for delivery. So goods are issued for and invoices are generated. So this reduces the manual intervention of the sales order or manual fiddling of the sales order drastically. It provides a lot of flexibility and deals with the last minute changes to fulfill the sales orders. So this is how we can reduce manual efforts in the order fulfillment process. We can improve the efficiency of the sales order fulfillment, reduce the inventory requirements, minimum inventory requirements to be maintained at plant, and optimize our order fulfillment process. Now we'll see the demo of these functionalities. The first one is supply protection. We'll see how supply protection works in this demo. So here we are going to MMPE and we are seeing how much stock of this material is available. So we see that for material 196, we have 50 quantity of material available at plant 1710. Now we'll create a supply protection object. Here we have created a supply protection object for at a material and plant level, material 196, plant 1710. We have assigned the planning horizon for supply protection is monthly, and we have assigned different customers to this supply protection object. So we have sold to party as our customer. There are two customers, 00005 and 00003. We have set up in the system different protected quantities. For first customer we have protected 10, for second customers we have protected 15. So this setup will ensure that if these are our high priority customers, at least, and this our monthly bucket allocation protection bucket is monthly. So the system will make sure that the protected quantity for this customer is not stolen by anybody else. So going ahead, we'll create sales orders for these customers and we'll see how this consumption of these protected quantities is done. 00005 is our C2, for whom we have protected 10 quantity. We have placed sales order of quantity 8. We had protected 10, so 8 has been consumed using the sales order. Now once we refresh the screen, we'll be able to see that out of 10, 8 is consumed and 2 will be remaining protection. So here we see consumed quantity as 8 and remaining protection is 2. So out of the protected quantity of 10, this customer has consumed 8 and remaining protection is of 2 for this customer now. We can also see this information graphically. So this bar chart represents how much was protected for this customer, how much he has consumed, and how much quantity is remaining, how much remaining protection quantity is available for this customer. If you wish to see which sales order has consumed this quantity, we can also scroll down and see, we can see the document number. This is the order number which has consumed the quantity. Our second customer has not consumed anything, so now we'll create a sales order for customer number 2, so 00003. This is our C1, customer 1. Protected quantity was 15. We'll try to create a sales order of quantity 22. We had only protected 15 and now we are creating a sales order of 22. So 15 quantity will be consumed from his protected quantity and the remaining will be consumed from the unprotected or open quantity. The sales order of 22 has been consumed, confirmed, and if we refresh this, we'll be able to see that the protected quantity has been consumed. See, 15 was protected, he has consumed 22, so remaining is 0. And the thing to note here is, even if the protection quantity was 15, 22 has been consumed, but the system did not touch the protected quantity of our previous customer. So the previous customer for whom we had protected 10, he had consumed 8 and remaining 2 quantity was remaining. So even if the second customer placed the sales order of 22, system did not touch the protected quantity of previous customer. So the supply protection ensures that once the quantity is protected for a particular customer, no other customer is able to steal that quantity. The remaining quantity consumed by this customer has been consumed from the open bucket or unprotected quantity. Here nothing is remaining, so in the graph we do not see anything remaining. You can see the sales order number which has consumed 22 quantity. Going ahead, we'll see one more case of a sales order for whom from a customer for whom we did not protect any quantity. Say for example this customer 00007, we did not protect anything for this customer. Now the unprotected quantity is 17. We'll try to create the sales order of quantity 22. System will only confirm the sales order for 17, even though the first customer had 2 quantity remaining. That 2 quantity is protected for that particular customer and no other customer will be able to steal that quantity. This customer uh, had requested for 22, he will get a partial confirmation, but the first customer who has quantity available or protected for him, that quantity will not be consumed by any other customer. So this is how we saw the examples of supply protection, how it works. Going ahead, we'll see the example of supply creation based confirmation. This is SBC, a scenario where the sales order triggers the production immediately. We'll see this example here. So we are creating a sales order for MTO scenario, make to order scenario. Here we are creating a sales order for a particular material for order quantity 30. As soon as this is a MTO scenario, make to order scenario, so there's no stock available for this particular material. As soon as the ATP check is triggered while creating the sales order, system is able to confirm the sales order and propose a date of 14th November as the confirmation date. Now this date, you must have noticed that it came immediately in a fraction of a second. In this fraction of a second, system uh, went on to check the availability of the resources, their capacities. Based on this capacity, system is available to provide this date of confirmation that this material for this much quantity will be produced and made available for delivery on 14th of November. All this process happened in a fraction of a second. Going ahead, we'll see how the system generated this. If you go to the product view, notice that we have not saved that sales order yet. We were on the ATP screen looking at the delivery proposal of the material quantity and the date. We did not save that sales order yet. Going into the product view, we can see that the planned order, we can see that the planned order has been created. And since we did not save the sales order, system treats it as a temporary requirement. It generates the planned order immediately by running its implicit logic, checking the availability of the resources, its capacities, and it generates a planned order and it proposes the date by when this material can be produced. Now it says temporary requirement because we did not save that sales order yet. The sales order number has not been generated. As soon as the sales order is saved, this temporary requirement will be replaced by that order number. We'll accept this delivery proposal and save the sales order. Order number 1524 has been saved. If we refresh this product view, we'll be able to see that the sales order number 1524 has been confirmed and the planned order has been converted to production order. Now you might think, what will happen if I do not save if the planned order is created during runtime, if I do not save the sales order, then what will happen? Will that planned order lie around without getting connected to any sales order for MTO scenario? It does not happen that way. We'll see that what happens if we create a sales order and we exit before saving the sales order. So here is an example. We are trying to create a sales order for quantity 25. This is the ATP screen. System has proposed 12th of November as the confirmation date based on the temporary requirement because we have not saved sales order yet. Going to the product view, we'll be able to see the planned order generated against the temporary requirement. 1253 is the planned order number. Now, if I do not save this sales order and I exit the screen, I'm exiting the sales order without saving anything. System will not keep that planned order. It will remove that and it will free up the resource capacities that was assigned for this temporary requirement. The temporary requirement is gone. The planned order that was temporarily generated, that is also gone. So system will free up the resource capacities if we do not save the sales orders. This is how the supply creation based confirmation is used. This helps in reducing the stockouts situation where the planned order production order is triggered automatically in a fraction of a second at the time of sales order creation itself. Going ahead, we'll see another demo of ABC, alternative based confirmation. So a situation where availability of the inventory is at a particular plant, the sales order is created at a different plant. System will try to confirm that sales order from the plant which has the material available. So here we see in MMPE for material 188, quantity of 20 is available at plant 1710, quantity of 40 is available at plant 1720, total 60 quantity of material is available. We'll try to create a sales order for this material. First, we'll have a look at our ABC setup. So we have created this substitution strategy. We have assigned plant substitution. Our building rule is full confirmation. So plant which is able to provide full confirmation, that will be selected automatically by the system. So here we are creating a sales order. We saw that quantity of 20 was available at plant 1710, quantity of 40 is available at plant 1720. So order quantity we are putting in as 25. Now we know that plant 1710 will not be able to fulfill that quantity. So system has automatically proposed plant 1720. Original plant was 1710. System detected that 25 quantity will not be able to fulfill from the previous plant. So system switched the plant to the one which is able to fulfill that much required quantity. In the sales order, you will be able to see plant has been changed to 1720 automatically. An order has been saved. So system automatically determined from where system will be able to fulfill the requested quantity. It as per the predefined strategy, and system confirm the sales order. Change the plant in the sales order automatically and confirm the sales order. So this is how we saw the demo of alternative based confirmation in aATP. So thank you. We have finished or done with the demos. We can take up any questions from anyone if we have. Naveen?
Yes.
Yeah.
So I'll quickly ask you the questions, Gaurav. So the first question that I see is, what is the difference between product allocation and supply protection? They appear to be somewhat similar.
Yeah, sure. That is actually a very good question. Product allocation and supply protection appear to be somewhat similar because they deal with the assignment of quantities, material quantities to a particular customer. But their functionality is a little bit different. I'll explain that. In product allocation, when we assign certain quantity to a particular customer, product allocation works as a quota or a upper limit for that customer. Say, suppose if I assign 100 quantity of material to a particular customer, that 100 quantity will be assigned to that customer, but the customer will not be able to consume more than 100 quantity. So it is used where there is a high demand and low supply of a particular material. Whereas if we use supply protection, we supply protection ensures that the customer will receive that much quantity, but he is allowed to consume more. See, for example, in supply protection, if I assign 100 quantity to a particular customer, system will make sure that that 100 quantity is not stolen by anybody else, that is reserved for that particular customer. But if my high priority customer wishes to consume more quantity, he is welcome to do that. So this is the subtle difference between uh, product allocation and supply protection.
Thank you, Gaurav, for answering that. I do remember, I think during the demo session, you did cover this aspect as well.
Yeah,
Perfect. So, moving to the next question. So, while using SBC, that is supply creation based confirmation, if my finished product has some components that are externally procured and are in shortage, then how can the system trigger production without the required component?
excellent question, Ravi. So uh, while in the during the MTO scenario, at the time of make to order scenario, it is possible that some of the BOM components or bill of material components are externally procured and not manufactured as a semi-finished product. So system checks the availability, component level availability, and if it is externally procured, so purchase requisitions are generated. Like in our demo, we saw planned order is created for the finished product. If the lower level components are externally procured, system is capable to generate purchase requisitions also for the components. So this is how system deals with this situation.
Got it. Thank you, Gaurav, again for answering the same. I think we have the last question before we close in. So, this gentleman asked, I want to reserve the decided quantity of a product for a particular high priority customer, and I want to make sure the customer gets the material, but I do not want him to consume more than a specific quantity so that the other customer can also receive the material. So, yeah, how
Right.
do
This is a genuine business need, Navi. So when we use product allocation, the need is that I understand that businesses want their customer, high priority customer, to receive certain amount of quantities. There might be some agreements between the customer and the uh, user, that the company, that they will provide this much quantity of material to that particular customer. But at the same time, they do not want their customer, high priority customers, to consume everything and keep other customers starving. So in such situation, we can use a combination of supply protection along. So our supply protection will make sure that minimum quantity is reserved for that particular customer. See, for example, I reserve 50 quantity for a particular high priority customer using supply protection. So system will make sure that that 50 quantity is reserved and nobody else, no other customer is able to steal that quantity. But at the same time, I do not want that customer to consume more than 100 quantity. So I can use a combination of product allocation along with supply protection, and I can set a upper limit or a quota limit for that customer of 100. So 50 is protected, he is welcome to consume more, but the maximum limit will be 100, and he will not be allowed to consume more than the allocated quota. So a combination of supply protection along with product allocation can be used in such situations, such business requirements.
perfect? So, I think there are two more questions that I see. So, Gaurav, in supply protection, do we have a standard process to upload quota or quantity?
Yeah, manually, currently we have a manual process to upload the quantities. Once the objects are generated, we can upload the quantities in the system manually as of now. The SAP has provided APIs for Excel uploads. So we can consume that API and build our application for Excel upload. We already have Excel upload functionality for product allocation, but for as of now, for supply protection, Excel upload functionality is not yet available. But SAP has provided the required APIs which can be consumed, and Excel upload functionality can be provided.
Perfect. I think that's a very valuable information that you provided. So, next is in SBC, will the sales order and planned order always be in a fixed pegging relationship?
It can be a fixed pegging. It can also be we can also use dynamic pegging. That depends upon the business requirement, and it also the pegging relationship can be controlled from the PPDS perspective. So aATP for SBC, aATP integrates very well with ePPDS, and there are different options in the PPDS side that we can explore as per the business requirement.
Perfect. Thank you so much, Gaurav, for answering that, and thanks, audience, for such a warm participation from there. And this brings us to the end of our webinar today. I thank you all for joining us. In case if you have missed answering any of the questions or you still feel to ask any questions with us, please do write to us at info@yash.com. That is info@yash.com. Till then, thank you so much. Thanks, Gaurav, for your support.
Thanks, Naveen. Thanks for the opportunity.
Yeah.
Wonderful connecting with everybody. Thank you.
Thank you, guys. You all have a good day.
Thank you. Bye.